Hello, everyone. Welcome to another episode of the Data Sense podcast. This is the show where you learn from business and technical leaders how to connect business and data to develop your own ability or sense to use data to drive your business forward. Today we have Ahmad Fattahi. Ahmad is a director of data science at TIBCO. Ahmad is publishing a book called IOT, Product Design and Development. This is coming out this fall. It's getting published by Wiley. Welcome, Ahmad, to the podcast. So, you're publishing a book. So tell us more about that. What got you into looking into IoT and product designing, and how is that related to data science?
Yeah, absolutely. First of all, glad to be here, and thanks for having me. By education, I'm a electrical engineer. I've been doing a lot of mathematical modeling, theoretical work with a underlying sense for how these electrical systems and electronic systems work and bring value to the society by education. With a lot of passion for software, and professionally, right after graduation in 2008, I joined a software company, OSI Soft, which is now actually owned by Aviva, and that opened my eyes to a lot of IoT type use cases and manufacturing business type of applications of collecting data and then all the analytics on the top for various use cases across the society, many of which are actually quite hidden from the eyes of the consumers. But those are the systems and the inventions that run a lot of what we use in the world. Following that, I joined Cisco for a couple of years, and now I've been here at TIBCO for a year. The collection of all of these ideas gave me a lot of insight into how these systems should work to bring value to the business and where the value is and how to define it, how to go about it, combined with, how to build the right team and have the right talents and skills and the challenges there. So at some point, because of one of my presentations, I was reached out by the publisher Wiley, and they were a couple of years ago, actually, they were putting together a series on IoT, and I agreed to work with them, and here we are. We are on the verge of publishing the book. Oh, I lost your audio.
So, sorry about that. That's quite interesting. So, with your current role, what is your biggest challenge in terms of business or technical? At TIBCO.
Sure. In my current role, we typically, our day-to-day job, week-to-week job is dealing with actual customer use cases and problems. We are a field data science team, so we get to know and see and touch and feel actual business problems by customers from various verticals, including manufacturing, energy, retail, financial sector, and a few more. And eventually we'll have to show that our creations, our software, and our algorithmic prowess can help our customers solve a problem. One of the technical challenges, if not the biggest, maybe it's the biggest one, is, the whole ecosystem is comprised of a lot of different moving pieces. When a typical customer shows up on our door, it's one thing to say in isolation, in a vacuum, this is your business problem, this is the translation to a technical problem, and this is how we can algorithmically think about it and put it in software. It's another challenge to then make it work in their environment, which is comprised of so many different pieces. It could be in AWS or Google with their own data centers, with a bunch of other systems, upstream or downstream. And mind you, all of these are moving systems, and updates and new versions, all of these permutations of these systems. Eventually, everything has to jive together and work well together. Building a reproducible system and software that works for the majority of these scenarios, that's quite a bit of challenge. So this is on the technical side. On the non-technical or less technical side, some people call it digital transformation. Pushing a technology is a great first step, but eventually it doesn't mean anything until and unless human beings actually adopt that. And that exposes many of our customers, and by extension us, to some of these other challenges that especially older and bigger organizations deal with. If some process is established for decades in a large organization, it gets so much more challenging to actually change that. So that change management and the cultural shift sometimes, those are some of the less technical and more like on the human and process side challenge that we have to deal with.
That's quite interesting. I remember I also worked on a small digital transformation project, and that involved changing a timesheets app from Excel to a bespoke web-based portal. And one thing we had to do to make it successful is actually show to everyone how it works, get them onboarded, get them bought into the new app, and then make sure that they're using it correctly, or limit the wrong usage of the software so that only the correct way can be used by those people who are the normal users. So that I can totally understand the sort of challenges where you introduce a new software and no one uses it and it's like sitting empty, or it could be costing a lot, and that can be a huge pain. So you mentioned that um, sort of setting up infrastructure or new projects is a huge challenge when you're obviously onboarding a new customer or developing something for them and then giving the code to them, or developing it on their system. Are these same challenges, or they're different in technically, in the sense that, do you always experience, oh, it's an issue because of security? There is an issue with each client because of it's different. Each client's environment is different. What would you say to that?
Yeah, it's more of the latter. There are some common issues that because they're common enough, typically over time they get absorbed into the products. Our software teams actually build those solutions into our products, but that's only a subset of the issues. At the end of the day, every customer's environment is significantly different from the other ones, except for super simple cases. So more often than not, both the source of the system can be unique. Source of the data, and the results and the way they want it, and the place, the platform they want it to show up can be also different, which poses every problem. Will be faced with some interesting challenges. So yeah, I would say it's more of the latter.
That. Yeah, I can imagine. And yeah, so just speaking from experience, I have the sort of experience where customers they have all sorts of problems, or all sorts of their infrastructure can be very different. So, and one customer is not, no two customers are same basically. No two environments are same. That's another one. And what I try to do is I try to engineer something on their system so that it fits nicely, so that we don't develop it and then transfer over. And what would you say to that? Is that something you have explored before, where obviously each customer's setup is different? Say, one has AWS, one has GCP. Even when you have two customers who have AWS environment, but their AWS setup is very different. how they've configured users and security, and different instances of AWS. What would you say to that?
Yeah, so if you have that luxury, that can help, but in many cases we don't, at least for a big chunk of the work, because we are a product software company.
Right.
So by extension, what you build should work in the majority of the cases. So that's that, and then leave the integration layer to custom work. So with that said, in many cases you can't even do that, and some of the creations of my direct team integrate with our software, so we treat them as official products, even though they may not be by our marketing team, they may not be considered official products, but we assume that they have to work in the majority of the cases out of the box, which poses quite a bit of challenge. A corollary of that is that we have to spend more time or invest more time in a proper technological design of any of these projects to make sure that it works in 80% of the cases, if not more. The documentation goes a long way, which may sound a fraction of the work, but you'd be surprised how many times the technical people, they're done with the technical implementation and the documentation doesn't interest them, which can be a big pain or big issue when it comes to adoption, and also support and services after the fact. So we have to deal with that. And that whole, running a viable business that produces something reproducible and reusable with a minimal amount of after the fact support and services, that's the big challenge. And you have to anticipate, like I said, moving targets when constantly AWS is shifting or improving their platform, which means our customers' environment is changing. So solving that equation in a way that you remain viable and profitable, that's the biggest challenge.
Yeah, that's quite interesting. I think I can imagine your challenge for being a product software company where you have a product and you're giving it to customers or setting it up on their infrastructure, and then you have to get back to obviously deploy it to the next customer and so on. So I can imagine that must be a huge challenge, especially when you're dealing with environments that have been set up so differently from one another. It's unbelievable. So if we go back to your book, you mentioned obviously it's a IoT book, and you're head of data science. Tell us, how do these two subjects correlate?
Yeah, absolutely. So to put everything in perspective, given my educational background in electrical engineering, so the hardware piece of it, the communication, all of that, that was something that I have some experience with. So that's that part. But overall, if we take a step back, I personally see this whole, what we call IoT and data science. Actually, in many cases, I see them as basically one story. Different people, like that whole old analogy, different people, touch the elephant in a different place on the body. But eventually it's one elephant. And in this case, for IoT, eventually we are talking about systems, machines that are built in a way that are versatile enough to connect with other systems, and you can put them in your business or in your house or personal environment, and they solve a problem. It can be a tiny problem or a big problem if you're a business for you. And in many cases, in almost all cases, it involves a significant data element. So the hardware and the communication part, those are enablements, but at the end of the day, those machines create some useful data that, first of all, should be handled properly by the hardware and the network and all of that. And on top of that, some sort of decision or prediction needs to happen based on the data that's produced reliably and at scale by all of these machines, which also means that I guess products on the top, they have a strong element of data and data science and analytics and machine learning on the top, which can be based on the user's personal data and that alone, or in some cases it can mean aggregation of a bunch of data sets and streams, and it poses data at rest and data in motion problems. So from that point on, it basically becomes a typical, very similar to other types of problems of when it comes to data science and machine learning. Not to mention that in some other cases, the initial motivation for an IoT project or product has a little bit of a data element to them. They solve the problem, the original problem, and then after the fact, they discovered that, we can actually start a new revenue stream by leveraging just the data or offer the data as a service. Examples of that there are some equipment manufacturers who, in manufacturing or energy, they built something, and just for the sake of bringing visibility and setting an alarm, they embed some data gathering and IoT in the equipment. It works, but then after the fact that they realize that, because we have visibility into 10,000 instances of this equipment, we have access and visibility into so much data, and we can build models, we can predict things because we have this massive volume. We can give access to other businesses to, offer service based on data, and we sit in the middle and create a new revenue stream. So it becomes, again, like I said, it becomes a cohesive picture of everything is at the service of delivering business value, and data is a big part of it.
Yeah, that's quite interesting. I also worked on a similar project, or quite a few projects. One was where we had sensors of water levels, or like flood sensors, I would say, deployed on UK highways, and that was just to measure water levels rising and dropping in the gutters, basically. And what that meant was, whenever the water is rising, you get a message sent out, and you have a warning that water is rising. When it when it drops, then you also get a message as well that it has dropped, and that was very useful data. Now the thing is that once you have so much of that data, you can build so many models on top of that. You can start. Then you have another. I would say just before you have like another stream of revenue, or I would say it's another stream, another source of data for the company to do even more sophisticated analysis of their whole system, that this is what the roads are doing, this is how much water is rising this here, and how we can monitor water rising based on the weather as well, and what patterns can we find. So first of all, bringing the data in, data engineering, and then doing machine learning on it, and then probably deploying those models on the cloud, or offering that sort of service that if the water rises, this will happen. This is what happens, and feed that data back to Met Office, or Met Office meaning the weather sort of department, and they can use that data. So they can use that data to also as an input for their models. So that's the sort of very powerful thing that can happen with just collecting data with IoT devices. So yeah, I can totally see that just makes sense. Now, another question I have, which is leading on from IoT and connecting to data science, what would you say about machine learning? Do you believe machine learning should be done on the edge, or should it be done on on the cloud? And what's your opinion on that?
Yeah, like most other things, it depends on a number of factors. So in my opinion, it's a, I guess, compromise or tension between two general principles or two desired factors. One of them is if you have access to more data from more instances, more devices, more consumers, anything like that. Typically, it means your models are going to be better at the training level. When you want to build a model, which the conclusion of that is you want your data to be at the training for training purposes to be farther in a server or in the cloud. That's one principle desired. Another principle is you want your compute to be as close to your data as possible. So data movement is minimized because it's number one, costly to move data. It can introduce delay when data needs to transfer. And also, every extra link exposes the data to more risk, security risk, and reliability risk. So that's the second desired principle, which points to, hey, push everything as close to the edge as possible. So these are two opposing forces. I guess, so there are all sorts of scenarios that you can imagine with all sorts of requirements and technical restrictions on power and delay and all of that. A typical scenario, and I have to emphasize it's one typical scenario, there are many different requirements and scenarios, that I'm seeing gaining traction in a good majority of the use cases is you would basically do the training at a central place like a cloud environment because number one, it first of all requires a lot of data from different environments. Otherwise, your model is not going to be very good covering all the situations. And number two, training is typically not that time sensitive, so you can tolerate delay. And also, training typically requires quite a bit more computational muscle behind it, so hence a cloud or server environment. Once the model is built, then you push the instances of the model for inference close to the edge. So inference is done at the edge, which has to be typically done much faster, and you don't push your data, live data, for security purposes, so you're safe there. And it typically takes much less computational power, so smaller footprint hardware closer to the edge can handle that. So that's a typical scenario that I see quite a bit. And then maintenance of the model for monitoring drift, because things change. That's something that can then be built on the top. So we can keep talking about this. The scenario continues, but that's a typical scenario that I see quite often.
Yeah, that's quite interesting. We did something similar, the typical scenario basically, where we got the data first, so measuring data, got the data back to a central place on the cloud, trained models using that data, and then pushed the trained model to the edge and using the Jetson NVIDIA chip, experimented with that first to do the inferences, and then if it worked fine, and which it did, then we deployed it, and it was a pretty interesting sort of ways of working, like how it gets updated. It's I guess another sort of dimension. It adds another dimension to your whole cloud, data, AI, machine learning, and then you have edge, right? Pushing the model to edge. So it's not, and the whole machine learning, the models creation, updating, and deployments. is another piece. You just need a few more people in the DevOps team to handle all of that. So that's the sort of thing I feel with IoT. So with IoT, what would you say is where is it most useful? Is it medical devices? Is it and would you say that an IoT device is not fully correctly functional unless it has internet? Um, could it work with just SMS? What is your opinion on that?
Yeah, it's so it can be everywhere. From you mentioned medical environments. There are, the whole consumer field is a big field. Like, our smart watches are continuously doing more and more with every update to monitor our health and activities. There, even in agriculture, there and water being a major issue, and food security across the globe. Having sensors in different parts of your farm in a reliable way to inform you this is the time to add water or add fertilizers, or the temperature of the soil is worrisome, to more, I guess, more easily imaginable use cases in a lot of various sectors of manufacturing and process engineering, discrete manufacturing. Energy is a huge topic. So I can go on and on.
Yeah.
Yeah.
Would you
So
would
the
you say
use.
that
Yeah. Yeah.
would you say that if the device does not have internet, it's not as useful?
So short answer, if you force me to say yes or no, I would say you're correct. If you take out connectivity, that's typically a significant blow to the functionality of your IoT device. However, there are situations that, for example, you have a pipeline or gas or oil pipe that goes for thousands of miles, and your business problem challenge is to monitor for leaks and conditions, or maybe rust on your pipe. And you go and install sensors across the pipe, which can be in very remote places. So you have to assume that sometimes the connectivity is not going to be as reliable. Other example is fire sensors across the forests. In these remote situations, you just have to put more resiliency in your design. But eventually, only a limited number of functionalities typically can happen on the spot, or decision making on the spot without connectivity. At some point, for most IoT devices, by definition, I is for internet. So if you take the connectivity out of it, that would be a stretch to call them IoT.
Yeah, that's a good way of seeing it. It is an IoT device at the end of the day. Yeah.
Right.
So, what do you advocate in terms of what's your what's your worldview? As in, is this a particular thing you see right now, and you feel like, what, if we worked differently, or if we managed differently, it would be better. What is like a one point you advocate for?
Are you asking for like our day-to-day work, or?
Yeah, so in terms of day-to-day work, in terms of technology, managing people, or working with technology, working with data, it could be how we hire, it could be how we work with technology. Yeah.
Yeah, sure. So, on the receiving side, if I'm doing a function, and there's something introduced to me by my organization or by my customer, or you name it, having a open mind and being open to change, and is a great thing. At the end of the day, I'm not saying every change is necessarily good, but many of them are. And by nature, sometimes we resist. If we are creatures of habit, and many of us are just by default are like, no, I'm good. I don't want to try this new thing because I've been doing this for years and I know how to do it. And we can give a speech for 30 minutes why we do not need anything new. So having an open mind is good. On the other side, if we are introducing something to our team or our organization or our customer, to make this process easier, it's always good to be close to the people, listen first, understand what actual business the audience is in, what is their day-to-day life and challenge, before showing up quickly and trying to be seen as the know-it-all smart person in the room, and because that can backfire. That's not helpful. And position whatever we are trying to pitch after we listen in, after we understand the day-to-day, the pain points, and make a judgment from there if what we are proposing and pitching for actually solves a real-world problem in the life of our audience. It's much easier said than done. When you talk about it, like when I'm saying it makes a lot of sense and it sounds easy, but in reality, you have to invest in it. You have to have a lot of patience, and you have to have open mind. Sometimes you face some fierce resistance, or sometimes even it can get political fights inside organizations because people might see that as, oh, I'm losing my grip on this problem because there's a newcomer. And I might not be seen as the expert anymore. So there are all sorts of challenges that can arise, and patience and paying attention to the actual bottom line business value is going to be helpful.
Cool. That's a great that's a great point in terms of and it's a great point to be arguing for, basically.
Right.
Yeah. So that brings us to the end of the podcast. Thank you, Ahmed, for being on the podcast. Just one more thing I would mention is you're also publishing a book called IoT Product Design and Development. This is coming out this fall. It's getting published by Wiley. So that would be great. I would be looking forward to that book. And hopefully we'll share the link of that book with our audience as well. Thank you.
I appreciate that. Thank you for having me.